It won't always be possible to live on Earth. We'll need to move to another planet if we want the human race to survive in the future. It seems simple until you consider the size of our solar system and how vast the universe is. Join us as we explore the unexpected JWST discovery that shocks the entire space industry. The JWST, or James Webb Space Telescope, has made a ton of observations in the unexplored, and scientists are overjoyed with its discoveries. This telescope has not only produced the stunning image from space that reveals galaxy clusters, but it's also interpreted significant data. The molecules that swirl and drift through the atmospheres of planets and other stars are difficult to identify despite the efforts of many astronomers who are up against formidable challenges. The first is that when attempting such measurements, they run into technological limitations. Second, many of the planets known so far seem to be shrouded in clouds and dust, which sadly blocks our view. The JWST has helped to alter the story. The JWST began its scientific operations on July 12th and has already made a significant discovery. The publication of pictures of 5 celestial bodies also shed light on its investigation of WSP-96b. The infrared spectrum, which measures heat rather than light, is used by the Webb telescope instead of the visible spectrum. Due to deep space gas and dust, Hubble would never be able to observe objects that are 13.6 billion light-years away. Like Webb, it is easily cut through by infrared light. Webb needs to be shielded from stray heat because it would distort its infrared optics, just as stray light would distort Hubble's visible spectrum. In order for the telescope to function, it must be very cold. That results in some fascinating design. The 6.5-meter, 21.6 feet wide primary mirror of the Webb is made up of 18 hexagonal segments that can be precisely moved along each of its 7 individual axes to focus the image for maximum clarity and detail. Because enclosing the mirror in a housing similar to the one for Hubble's primary mirror would trap heat, the mirror is left exposed to space. Additionally, it doesn't revolve around the Earth, where the never-ending cycle of day and night would cause jarring temperature variations on each orbit. Instead, it keeps up a station 1.6 million kilometers or 1 million miles from Earth. At this location, known as a Lagrange point in space, the gravitational pulls of the Earth and the Sun cancel one another out. Hubble and WEBC cannot be compared to one another in the same way that a 70-year-old and a 71-year-old can, according to Scott Friedman, an astronomer on the Webb team, in an interview with Time from last year. It is comparable to contrasting a newborn with a child who is a year old, in which case there is a notable difference between the two. WSP-96b is a gas giant planet that orbits a Sun-like star 120 light-years from Earth. WSP, which stands for a wide-angle search for planets, has a mass slightly higher than Jupiter's but lower than Saturn's. Whatever the reason, observations made in 2018 from the ground showed that this particular planet is free of any sky distractions. Astronomers are interested in it because there are no clouds covering its atmosphere. WSP, an exoplanet, is categorized as a hot Jupiter. The existence of sodium-rich, hot gas giants outside of our solar system has long been accepted by astronomers. It is the 7th most common element in our universe. This particular element has not been found in earlier exoplanetary studies due to cloudy atmospheres because of its weak signatures. However, WSP's clear skies have completely changed the course of the narrative. Its presence allowed for the identification of WSP-96b and may also provide information on the planet's environment. On Earth, sodium controls both human and animal metabolic processes. Our crust contains about 2.6% of this element, which is frequently found in our seas. The sodium concentration is similar to the solar system's ratios. Because it contains sodium and other elements found in our solar system, the planet's circumstances as it transits or appears to move in front of its star may also be fairly similar. From our vantage point, the transmission spectrum shows molecules in the planet's atmosphere. Certain wavelengths of the star's light cannot reach us because of molecules in the planet's atmosphere. As a result, the spectrum exhibits dark absorption lines that serve as the molecular signature of the environment. The spectrum is reversed in the first set of Webb images, making it easier to see where the most light has been blocked. According to a NASA statement, Webb's observation in red and infrared light reveals cloud signs in a hazy sky. The clouds can mask the absorption signature of water in WSP-96b's atmosphere, as well as some of the spectral signatures of molecules emitting from beneath clouds. Exoplanets with extreme temperatures have cloudy atmospheres. Prior to WSP-96b, cloudy atmospheres were only present in hot gas giants. The discovery of a cloudless atmosphere allows scientists to compare the outlier to its cloud-rich siblings. The research team will be able to comprehend why clouds favor the majority of hot gas giants, while ignoring WSP-96b by contrasting their differences. University of California, Santa Cruz astronomer Jonathan Fortney thought this was amazing to witness. It was unexpected to see clouds where none were anticipated, he continued. I don't know what to say. However, in 2018, using only visual light, the Very Large Telescope in Chile found a strong trace of sodium in the atmosphere, leading scientists to believe the WSP-96b had no clouds. Recent observations made with the telescope, the Magellan board at the Los Compañes Observatory in Chile, have confirmed this discovery. Astronomers are reanalyzing both the Webb observations and the earlier optical observations to better comprehend the behavior of WSP-96b's atmosphere and the connection between its molecular composition and cloud levels. They are puzzled by the surprising contradictions in the results. WSP-96b may or may not have clouds, but one thing is for certain: there is no such thing as life as we know it there. WSP-96b, a bloated gas giant, is heated to nearly 1800 degrees Fahrenheit or 982 degrees Celsius and moves so quickly around its star that it completes one orbit in just 3 to 4 days on Earth. The results show off Webb's extraordinary toughness and sensitivity. Although the Hubble Space Telescope found water on exoplanets in 2013, earlier detections required more observations. It has been established that water exists in the atmosphere of exoplanets. On June 21st, however, the Webb slitless spectrograph and near-infrared imager detected the water absorption lines in just one observation lasting 6.4 hours. As you might anticipate from Webb, the resulting transmission spectrum is the most precise one ever acquired of an exoplanet. While astronomers from all over the world are already clamoring to reserve time for Webb to research fascinating objects in the years to come, the research Webb will conduct in the future won't be completed for a very long time. Despite the incredible size and beauty of the universe, today is all about the glitz. Webb is releasing all of this to the public, greater than any observatory before it.